An element A forms an oxide with formula A2O3. What is the valency of A? So we have A2O3, which means A has valency 3, O has valency 2. So valency of A equal to 3. Which postulate of Dalton's atomic theory is the basis of law of conservation of mass? Atoms can neither be created nor destroyed. So the basis of the law of conservation of mass is the following postulate of Dalton. Atoms can neither be created nor destroyed in a chemical reaction. That means mass is conserved. Valency of an element A is 4. Write the formula of its oxide. So valency is 4, oxygen, you know, valency is 2, you crisscross, becomes A2O4, you take 2 common out, become AO2. This will be its oxide. An element has valency 3, X has valency 3, so let's write that, and Y has valency 2. Write the formula of a compound XY. So the valency will crisscross, X will take up the valency 2 and Y will take up the valency 3. So this will be the formula of the compound. State the law of conservation of mass. According to the law of conservation of mass, mass can neither be created nor destroyed in a chemical reaction. This also implies that in a chemical reaction, the total mass of products is equal to total mass of reactants. There is no change in mass during chemical reaction. So mass of reactants equal to mass of products. Give the significance of mole. 1 mole represents 6.022 10 raised to 23, maybe if it is atoms or molecules or ions, depend what specimen they've given. And 1 mole also is equal to gram atomic mass of the element. What does it mean? We know the gram atomic mass of carbon is 12. Gram atomic mass of carbon is 12 gram, which is equal to 1 mole. Another example to take, say, gram atomic mass of oxygen, 16 gram, means equal to 1 mole. Oxygen atom. Which postulate of Dalton's atomic theory is a result of law of conservation of mass? The postulate of Dalton's theory, which is a result of law of conservation of mass, is mentioned here, is atoms are indivisible particles which cannot be created nor destroyed in a chemical reaction. This is important. Atoms cannot be created nor destroyed in a chemical reaction. This has the same implication as law of conservation of mass. How many atoms are present in a phosphate ion? So PO4 minus 3 contains 1 phosphorus, 1 atom of phosphorus, and 4 atoms of oxygen. So total atoms equal to 5. State the law of constant proportion. It was introduced by Proust In a chemical substance, the elements are always present in definite proportions by mass. And if you remember, we took the example of water. In water, you have hydrogen and oxygen, and the ratio is always 1:8. Then there was another example given, ammonia, NH3. Ammonia consists of nitrogen and hydrogen, always present in a ratio 14:3. An element Z forms an oxide with the formula Z2O3. What is its valency? So Z2O3. Z will have the valency 3 and oxygen has valency 2. So valency of Z is +3. The one that is in the front is always positive. Here this is negative. So Z will have the valency 3. And oxygen, of course, we know the valency is 2. The valencies exchange. Calculate the molar mass of the following. First, we'll take ammonium sulfate. So we have NH4 twice SO4. So in this bracket, I have 1 nitrogen plus 4 hydrogen, bracket 2, this 2, right? And in the other bracket is of sulfate. So here I have 1 sulfur plus 4 oxygen. So let me do nitrogen. 1 nitrogen is 14, 4 hydrogen is 1, and this whole bracket here, this is 2. Like here we have the 2 here, right? This whole bracket is 2. So we put this bracket now is 2. And in the other bracket we have 1 sulfur is 32 plus 4 oxygen. Oxygen we know is 16. So in the first bracket we'll have 14 plus 4, close the bracket, there are 2 of them. We solve this first. So we have 14 plus 4 is 18. 18 into 2 plus, here we have 32, 16 into 4, which is 64. So the total here becomes 18 into 2 is 36 plus 32 plus 64, and here is 132 gram. That will be the molecular mass of ammonium sulfate. Now next we'll go to penicillin. It's a long compound. It is C16 H18 N2S and O4. So first we have 16 carbons, 18 hydrogens, 2 nitrogens, 1 sulfur, 4 oxygen. So 16 carbons means 16 into 12, and here 18 hydrogen is 1, nitrogen is 14, sulfur 32, this will be given to you, and oxygen is 16. So 16 into 12 we have 192, then we have 18 into 1, which is 18, 2 into 14, that is 28, 1 into 32, that is 32, 4 into 16, and this is 64. You add them all up and you get 334 gram. Next is paracetamol. This is the medicine we take when we have fever, like crocin. So it is C8H9NO. So here paracetamol, 8 carbon, 9 hydrogen, 1 nitrogen, 1 oxygen. So 8 carbon, 8 into 12, hydrogen is 1, this is nitrogen 14, and 1 oxygen. So first 8 into 12 is 96, plus 9 into 1, 9, plus 1 into 14, 14 plus this would be now 1 into 16. Then you add them up and this would be 135 gram per mole. Calculate the formula unit mass of zinc oxide. So we have zinc oxide will be 1 zinc plus 1 oxygen. Atomic mass of zinc they given is 65. So 1 into 65. Oxygen is 16. It's given to you. So 65 plus 16. This is 81 U. Next is sodium oxide, Na2O. That is made up of 2 sodium plus 1 oxygen. Sodium 23, oxygen 16. So this is 46 plus 16 equal to 62 U. Next is potassium carbonate, and that is K2CO3, 2 potassium, 1 carbon, 3 oxygen. Now potassium is given here 39, 1 carbon that is 12, 3 oxygen 16. So here we have 78 plus 12 plus 48, and you add them, you get 138 U. Calculate the molecular mass of each. This you can do on your own. Here I'll just write the answers. This will be like 2 hydrogens, 2 into 1, so that will be 2U. Then oxygen will be 2 oxygens, 2 into O, that will be 2 into 16, 32U atomic mass units. Chlorine will be 2Cl, 2 chlorine atoms, that is 2, 35.5, and this is 71 U. Then we have for carbon dioxide 1 carbon, 2 oxygen. 1 carbon is 12, 2 oxygen is 32, and that answer will be 44 U. Then we have methane CH4, 1 carbon, 4 hydrogens, which will be 12 plus 4 into 1. You add that up and you get 16 U. Next is C2H6, 2 carbon, 6 hydrogen. That is 2 into 12 plus 6 into hydrogen is 1. And you add that up together and you get 30 U. Next is C2H4, so that is 2 carbon, 4 hydrogen. 2 into 12 plus 4 into hydrogen is 1. You add that up together and you'll get 28 U. Next is ammonia, 1 nitrogen, 3 hydrogens. 1 nitrogen is 1 into 14 plus 3 hydrogen. You add those together and you'll get 17 U. And last is ethanol, 1 carbon, 3 hydrogen, 1 oxygen and 1 hydrogen. So that is 12 plus 3 into 1. Oxygen is 16 plus 1 into 1. You add this up together, you get 32 U.